Okay, so part B of 13.62 is to find the amount of additional work required to move the craft from our low orbit from before to a great distance from the Earth, ignoring the effects of gravity from the Sun, the Moon, and any other planets and stars it might encounter on its journey throughout the universe. So, we pretty much just use our adapted form of the work energy theorem from before. Our work is equal to our second energy, the energy that it has while it's out of low orbit, minus the energy it has while it is in low orbit. So, the kind of fun thing about this is that our second energy here goes to zero. Because once it's out of the Earth's gravitational pull, once it's out of low orbit, there's no more energy acting on it. So that just goes to zero, so here we have a negative E1. And we remember from part A that our E1 in this case is our E2 from before, because that's our starting point, and our E2 was equal to the gravitational constant times the mass of the Earth, negative gravitational constant, mass of the Earth, mass of the particle over 2r, radius of the Earth. So, this becomes the negative, or just positive, gravitational constant, mass of the Earth times the mass of our particle over twice the radius of Earth. And you may notice that is exactly what the work required to get it from the surface to low orbit is from part A. So we can just go straight into part C, where it says to justify in terms of energy the statement that low orbit is halfway to the edge of the universe. The reason for that is because these two values are equal. It takes exactly the same amount of work to go from, here's Earth right here, to go from low orbit to the edge of the universe. So low orbit in terms of energy is halfway to the edge of the universe. Kind of cool.